smooth this because I smoothed it out. We're done. So if you want to see how it looks like, you can plot it here. That's the real part, and you can also plot the dielectric, the imaginary part of the dielectric, and this is wavelength. So once we do that, then we can define this material property as a function of lambda. So the way Comsol understands functions is with parentheses, so it's going to be a function of lambda, and that's why I didn't write units up there. And then we're going to put the imaginary part. Now, because of a convention of sign, Comsol requires negative imaginary part. When you have a wave, you can have e to the minus I kx or e to the plus I kx, and because of the sign convention in Comsol, you need to put the negative. Comsol, the imaginary number, it understands I or j, either one, times epsilon g imaginary part of lambda. So this is the name that I gave to the functions up here. Epsilon for dielectric of silver, the imaginary part, and epsilon of silver, real part. So that's what I have here. And then that's going to be happening in domain 7. So you click air, everything is air. But now domain 6 and 7 got overridden. Domain 6 being glass, or close to it, and domain 7 being silver. So we're done with materials. Next, we have our physics. So let's bring this back. So I want to add perfectly matched layers. And where are they going to be? Clicking here resets everything. Left click, right click, it adds it. So this is going to be perfectly matched layer. It's only selecting the shell, it's not selecting the inside, and we're done with that. Type spherical, perfect. And these factors, it works well. You rarely have to change them. We could add scattering boundary condition, but in this version, it doesn't allow for spherical scattering. There is a slight bug. So I'm going to use Cartesian, but we're safe just because the PML works fine. We'll see that the field doesn't even get there. Scattering boundary condition, plane wave, that's fine. Okay, so we're done there. Now we need to mesh. I want to deselect everything, so I press Ctrl D. I clicked on the geometry and pressed Ctrl D. I'm going to add a free triangular mesh first. And I will add that in the outer in this inner shell. So that's the first thing that I want to mesh. I'm left clicking and right clicking, and that adds it automatically. And now I say mesh selected, mesh that. Now I want to sweep that across my PML, my perfectly matched layer. So right click on mesh and swept. And then not remaining, we're going to sweep the domain. So then deselect, reset hiding, and we're going to do it in the shell again. This is just selecting the shell. And then build. Click there, and so then right click on the swept, distribution 5, do. Okay. Now I'm going to add free tetrahedral for the rest. Size, fine. I right click, free tetrahedral, added a size, and then that size is going to be fine. So the remaining of the geometry is going to have that size. This size is a general size. So free triangular only works in these boundaries, which is the inner, inside the shell. Then it sweeps to the outside, and then the rest is meshed like this. So mesh all. And now let's see if it did it. So here it is. It has 5 because in distribution we said 5. If we want more, we can put more, but it's advised to do 5 or 6 elements so that you can really absorb the wavelength. So what's going to happen is the sphere is going to scatter, and the PML are going to absorb the scatter wave. It's not going to reflect back because that would influence our results. So we're meshed. We can right click here, show default solver. Actually, in electromagnetic wave, we are going to solve for the scatter field, and then we have to enter the field. So I want the field to work in all domains. I want the field to have an amplitude of V0. It's going to be on the y direction. That's why it's very convenient to have YZ like this, because the field is going to be in the y direction. Exponential. Comsol has certain functions, and that's how it understands an exponential. J times 2 times pi divided by lambda, where lambda is in meters and lambda is multiplying z. So the wavefront is going to move in z because 2 pi over lambda is the k vector. So it's going to move in z, but the electric field is going to be pointing in y. So as a function of time, it'll move and it's going to be pointing in y. And in the parameters, it knows who is lambda. So if we want to check that the field that we're putting is correct, we can open solver. We open dependent variables, right click, compute to selected. We have to wait. Okay. Then you have 3 slices. I'm going to disable these ones. I just want the slice that has YZ. Disable. And then this slice has YZ only one. So you can see it's only one slice in the YZ plane. And the norm is constant everywhere, and in the PML is absolutely perfectly 0. But if we want to see the Y component of the field, then we set it plus.